Assalamualaikum and good day to all the panelists and my viewers of my presentation video. My name is Ahmad Hakimi bin Ahmad Mirza, and today I will be presenting my final year project MEC601 with the title Lubrication of Porous Materials Closed Cell Using Computational Fluid Dynamics (CFD). And my supervisor is Dr. Roselina Binti Roseley. First of all, we will go through the project summary. First, this work aimed to predict the lubrication behavior of nickel titanium closed cell porous materials with different porous size and surface. Next, computational fluid dynamics (CFD) analysis will be used to investigate the lubrication behavior of the nickel titanium closed cell porous materials. And lastly, to generate and simulate the 3D model of nickel titanium closed cell porous materials by using NCIS fluid. Now, we will go through to the introduction. Tribology. What is tribology? Tribology is the research on the science and engineering on relatively moving surfaces. Tribology have major impacts in modern applications such as biomedical, industrial machinery, and also nanotechnology. And tribology also involve the study and application of concepts of friction, lubrication, and also wear. Porous material. What is porous material? Porous material is types of materials that has low density, broad surfaces, and a range of different physical, mechanical, thermal, electrical, and acoustic characteristics. Porous material also has been widely used in many applications such as surgical implants, impact energy absorbers, thermal insulators, porous metal bearings, filters, and also heat exchanger. Computational Fluid Dynamics (CFD). CFD is the branch of CAE that simulates fluid motion and heat transfer using numerical approach. CFD software can analyze a range of problems related to laminar and turbulent flows, incompressible and also compressible fluid, and much more. Next, we will go to the literature review. Shape of porous materials. Shape of porous is varies and not fixed. Normally, the shape of porous is randomly distributed or ladder-like appearances. The first picture shows a randomly distributed porous shape, and the second picture shows the ladder-like pore shape. Next, fabrication method of porous material. There are several methods in fabrication of porous material. The first one is mold casting. The second one is freeze drying. The third one is rotary sintering. And lastly, the most common use in industry to fabricate porous materials is spark plasma sintering. Next, types of porous cell. Basically, there are two types of porous cell, which is closed cell and also open cell. For closed cell, the pores are isolated and not interconnected. Closed cell also has low density, high thermal conductivity, and usually the percentage of porosity in closed cell are low and also middle. For open cell, the pores are usually interconnected. And for open cell, it has high density, low thermal conductivity, and in open cell, the percentage of porosity is normally high. Next, lubrication of porous materials. Porous bearings were commonly used in industrial applications due to their self-lubrication characteristics. Based on previous research by Yin and Zhang in 2018, the reduction of porosity in bearings can prevent oil from seeping into the porous medium, thus increasing the bearing strength and hydrodynamic capacity. Besides that, by increasing the velocity, the lubrication property of single and double layer oil bearing can be improved. Besides that, Yin and Zhang also stated that the friction coefficient are affected by the load capacity. When the load capacity is increased negatively, it will positively increase the friction coefficient. On the other hand, having a lower surface porosity is advantageous to enhance the lubrication performance of the bearings. Next, the porous materials and its tribological behavior. Porous material has been widely used in powder metallurgic geomaterials. Powder metallurgic geomaterials has an underlying porosity that resembles the surface texture. Applying a texture on a sliding surface will decrease friction and wear since the surface texture functions as oil reservoir that permit good lubrication. Based on previous studies, pin on this test was commonly used to investigate how different size of pores can affect the friction and wear. Pin on this test. There are three materials were used to manufacture the pin and disc, which is steel RS, distaloy AQ, and acetaloy CRA. During the test, the coefficient of friction of RSAQ and RSCRA is increasing when the size of pore decrease, which means if the pin and disc have different material, the coefficient of friction will increase when the size of pore decrease. While on the other hand, the coefficient of friction of CRA and AQ is decreasing when the size of pore decrease, which means when the pin and disc has the same material, the coefficient of friction will decrease when the size of pore decrease. Next, nickel titanium porous materials and its tribological behavior. Nickel titanium porous material. Nickel titanium has stable memory effect, very good corrosion, and also resistance to wear. Nickel titanium porous material have many applications, include micro electromechanical system, medical implants, actuator, and also aerospace industries. Nickel titanium also, one of the method of fabricating porous materials is by powder metallurgy. Properties of nickel titanium. The table shows a few properties of nickel titanium. As we can see from the table, the nickel titanium porous materials that has the lowest percentage value of porosity, the smallest the smallest size of pore, and also the shape that is irregular has the highest elastic modulus and also the yield stress. Based on previous study by Sharma in 2017, the wear rate and friction coefficient of nickel titanium are affected by the rotational speed of wheel. This is caused by the heat generated by the wheel. This table here shows the wear rate of nickel titanium. As we can see, as the RPM or rotational speed of wheel increase, the wear rate will also increase. And this is the graph of coefficient of friction of nickel titanium. As we can see, as the rotational speed increase, the coefficient of friction of nickel titanium will also increase. Now we will go to the problem statement. The investigation on porous materials can be a crucial step towards improving its tribological characteristic. However, there is less study that focus on the tribology of nickel titanium closed cell porous materials. Hence, the study will answer the following research question, which is, what is the lubrication characteristics of nickel titanium closed cell porous materials? Objectives of this project. The aim of this work is to have understanding on the lubrication behavior of nickel titanium porous materials, which can be used to predict its tribological properties for the development of new design of porous nickel titanium with good tribological behavior. The objective of this project are as follows. The first one is to generate CFD model of nickel titanium closed cell porous material, and the second one is to assess the lubrication properties of nickel titanium closed cell porous material. Now, the scope of the project. This research will focus on the tribology of nickel titanium closed cell porous materials. The modeling and simulation will be done by using computational fluid dynamics. The scope of work are as follows. The first one, throughout this project, the porous size is between 7.787 mm to 31.835 mm. Second one is the arrangement of porous are randomly distributed. Limitation of this project. In this work, the size of the meshing is set to 2 times 10 to the power of negative 002 meter due to the limitation of element size of ANSYS for student version. Next, we will go to the methodology of this project. First one, start with the literature review on tribology of nickel titanium closed cell porous material by previous researchers. Next, after we have done with the literature review, modeling of 3D of nickel titanium closed cell porous material. Next, run a simulation setup by using ANSYS Fluent. Next, obtaining the result of the simulation, and finally, to do report writing and submission of the project. Expected result from this project. At the end of this work, the following results may be expected. First, understanding of the lubrication behavior of nickel titanium closed cell porous material. Next, development of 3D model of nickel titanium closed cell porous material by using CFD. This is the 3D model of porous material, and this is 3D model of porous material with meshing. The mesh properties are as follows. For the knots, the value are 14,695. For the elements, the value is 67,924. Fluid flow in closed porous medium. The fluid used is water with density of 998.2 kg per meter cube. And the viscosity of water is 0.001003 kg per meter second. And the velocity magnitude at the input is 2 meter per second. Now we will see a simulation video on water flow through a porous medium and also water flow through non-porous medium. The first video is water flow through porous medium. Second video is water flow through non-porous medium. Okay, so as you can see from the simulation video, when the water flows through non-porous medium, the speed of water, the water travels faster compared to when the water flows through the porous medium. Next, when the water flows through the porous medium, the water volume fraction is randomly distributed due to the pore shape. That's all from me. Thank you. Assalamualaikum.